Welcome to homework.
This is the answer to chapter 22, problem number 62 from the Smith Organic Chemistry textbook. And this problem is asking us to draw a stepwise mechanism for the opening of this lactone in the synthesis of an important intermediate. And so the first step in this reaction is going to be OH acting as a nucleophile and attacking this electrophilic carbonyl carbon. And so simultaneous to that happening, these electrons from one of these two carbon-oxygen double bond bonds will revert to this oxygen. So we now have a tetrahedral intermediate. The oxygen that was formerly double bound to the carbon has an extra lone pair and a negative charge on it. And so that one of those lone pairs is going to reattack the carbon and reform the double bond. And so while that's happening, this carbon-oxygen bond will break, and those electrons will revert to that oxygen. So we now have this intermediate, which very closely resembles the final product that we were asked to account for. But this oxygen is missing a proton. It has an extra lone pair, and it has a negative charge on it. And so you might think at this point, well, we can draw a molecule of H3O plus or a molecule of water just protonating this oxygen. And that would give us our final product. But actually, the correct mechanism is that a proton transfer is going to occur. So this proton is going to go from this oxygen over here to this oxygen with negative charge. And the reason for that is, let me change my color just to make it apparent. So this system here, this carboxylic acid-like system is better able to stabilize a negative charge because what you actually have when one of those, when one of those oxygens has a negative charge on it, what you actually have is this, where rather than one being double bound and one being singly bound, they charge in them and they share the double bond between them. So something like that. So it's better able to stabilize the negative charge. And so we don't really draw this proton transfer. We can just write proton transfer. And so now you can see that oxygen here has the proton in question, and the oxygen over here has the negative charge and the extra lone pair. And now, as we said, we can use some H3O plus in this example. So there's our H3O plus. It's willing to give up a proton. So one of the lone pairs on that oxygen can grab that proton. Those electrons will revert to that oxygen. And now we have our final product over here. I can't speak to whether or not your professor would take points off if you omitted that step. I know for me it would be all right if you wanted to just protonate here and call it. But you do need to know that in this instance, you would have this proton transfer, and then you would protonate the carboxylic acid functionality over here. And so that is the answer to chapter 22, problem number 62.